Hello, Mr. T again. This is part 2 of our graphing logarithm functions tutorial, and we have a problem up here, y equals log base 3 of x plus 2. So in this case we don't have a value added or subtracted to the x, so our h is 0 and our k is the plus 2. So we will be factoring that. Now to get started, we're going to write just the base part of this, so without the h and k. So that would be log base 3 of x. And we're going to make a table of values for that. Now if you remember in the last tutorial, what we are interested in is looking at the exponential form of this function, which would be 3 to the y equals x. And we're going to make our table of values, and we're going to pick the y's. So I'm going to pick -1, 0, and 1, and calculate the x's. So this would be 3 to the -1, which is 1/3. This would be 3 to the 0, which is 1, and 3 to the first, which is 3. So our points on the base function are 1/3, -1, 1, 0, and 3, 1. Now since we have a k affects the y values, so we need to add +2 to each of our y values for the points that we're going to graph. So we have the point 1/3, 1, 1, 2, and 3, 3. Those will be the points on the graph that we show. So let's just show those to first. So if this is, let's do here 1, 2, 3, 1, 2, 3. So we'll use every other tick mark. So if we go to 1/3, 1, we have a point here. If we go to 1, 2, a point here. And our third point is at 3, 3. Since h is 0, our vertical asymptote is still the y-axis. X equals 0, our vertical asymptote. And we can sketch our graph now, asymptoting towards that vertical line and continuing out through the points. And our domain is going to be x greater than 0, and our range again is all real numbers. So again, this was an example where we had a k value. Let's look at a value now, a problem where we have an h value, so that's our second problem here. I'm also in this using the len function. So remember, the len of something is the same as log base e of x plus 3. Now in this problem, our h is -3. Now we take the opposite of this number inside the parentheses because in our template we had x minus h. So for that to be true, h would have to be a -3. There is no number added or subtracted to the end, so our k is 0. So in this one we will be adjusting the y values. Our exponential equivalent function here would be e to the y equals x. And again, we are looking at the base function, which is just log base e of x, or len of x. Let's make our table of values again. And again, we're going to pick our y values first, -1, 0, 1. So here we get e to the negative first power, which is 1 over e, and if you put it in decimal is approximately 0.4. Here we have e to the 0, which is 1, and e to the first, which is approximately 2.7. So our base points are 0.4, -1, 1, 0, and 2.7, 1. Now we have to subtract 3 from each of those, so we get -2.6, -1. We're subtracting from the x's. -2, 0, and -0.3, 0 as our y values. And we plot our points. So we have I'm going to run out of time here. We'll continue in the next tutorial to finish the graph, sorry. So you'll have to wait for the next tutorial to see what it looks like.